Boys and girls, this is Mr. Manise here again with another super cool video. And in this video, I'm going to walk you through how to solve each of the problems on the radical equations and rational exponents quiz review. My disclaimer is always, I need you guys to work these problems on your own and then and only then come to the video and see where you might have made some mistakes or clarify any misunderstandings that you have. Okay, radical equations first. How do I know that I have a radical equation? I have a radical at some point on either side of the equal sign. And what we learned during this lesson is when I'm trying to solve these guys, I must isolate at least one of the radicals by itself. Now, if I only have one radical, like in number 1, then I just need to get it on one side of the equation. If I have multiple radicals, like in number 4, I've got to isolate one of these guys, and it doesn't matter which one is which, okay? Once I isolate the square root or the radical, then I will take the square root of both sides, and then I will solve. So in number 1, this one's pretty easy. I have the radical isolated by itself, so I'm simply going to square both sides of the equation. Whenever I square a radical, I just get itself. Okay, so if I take, for example, if I take the square root of 3 and I square that, that's the same thing as the square root of 3 times the square root of 3. Square root of 3 times the square root of 3 is the square root of 9, and the square root of 9 is just 3. So when I square the square root of something, I just get what's left underneath the radical, okay? So when I squared the square root of 4b minus 4, I'm left with what's under the radical, which is 4b minus 4. And I square the 4, that's going to be 16, and now I have a simple algebraic equation that I want to solve. 4b is equal to 20, divide by 4, and I get b is equal to 5. However, we must remember to check for extraneous solutions. An extraneous solution means a solution that you get when you do all the math, you solve the equation, you solve the radical, you solve the polynomial, but when you plug it back in, it doesn't work. Okay, so we've got to take each of our answers and stick them back in there and make sure I don't have a negative underneath the radical. Okay, so when I plug in 5, 4 times 5 is 20. 20 minus 4 is 16. The square root of 16 is 4. So I have 4 on the left, and I have 4 on the right. So check, that works. So that is a solution. Number 2, I have a radical on the left, I have a radical on the right. They're both isolated, so I can simply square both of them. All right, when I square both of these, the square root symbol just goes away, and I'm left with negative 1 minus 5a equals 1 minus 3a. Let's get a positive variable, so I'll add 5a to both sides. I'll subtract 1 from both sides. Those cancel, those cancel. So I have 5a minus 3, I have 2a equals negative 1 minus 1, negative 2. Divide by 2, and we get a is equal to negative 1. Let's check that bad boy and see if it works. So if I stick in a negative 1 for a, I have negative 1 minus 5 times negative 1. Negative 5 times negative 1 is a positive 5. Positive 5 minus 1 is 4, and the square root of 4 is 2. All right, if I stick in a negative 1 here, I have 1 minus 3 times negative 1. That's going to be a plus 3. 1 plus 3 is 4, and the square root of 4 is 2. So that also works. No extraneous solutions so far. All right, and the next one, I have the radical isolated on one side of the equation, so I'm good to go. I'm ready to square both sides. Okay, the square root just drops out, so I have 2n minus 6. But now when I square the opposite side, and guys, you have to square the whole entire side, okay? You cannot square each of these guys individually, okay? So don't make the mistake of coming out here, maybe do this in a different color. Don't make the mistake of coming out here and doing n squared minus 3 squared. Okay, this is not a distributive property here. I can't do n squared and then minus 3n squared. Okay, so because let's say I have, let me just kind of go off the scale here. Let's say that I have 2 plus 4, and I want to square that equals whatever, blah blah blah. There's a big difference between squaring that and doing 2 squared plus 4 squared. Watch what happens. 2 plus 4 is 6. 6 squared is 36. 2 squared is 4. 4 squared is 16. 4 plus 16 is 20. Okay? These are not the same thing. So when you square one side of the equation, you got to square the whole thing. Okay? Oh, orange and purple. Such beautiful colors. Okay. So now when I square this, when I square n minus 3, that's a perfect squared trinomial. Okay, so if you know the shortcut, then you can just go to the shortcut, or if you want to, yes, you can just FOIL this out. N minus 3 times n minus 3 first, n squared, outside negative 3n minus another 3n, that gives us our negative 6n, and then negative 3 times negative 3 is positive 9. Okay, so if you remember the shortcut, you square the first term, you square the back term, n squared and 9, you multiply these two guys together and double it. So negative 3n doubled is negative 6n. All right, and now I have a quadratic that I need to solve. So I want to set this guy equal to 0. So let's subtract 2n and add 6 to both sides. Okay, so I have n squared, that's going to be minus 8n plus 15. Set that equal to 0. Are there any factors of 15 to add to 8? Why, yes there are. That's going to be a 5 and a 3. And they're going to both be negative because they have to add to a negative 8. And so then I'm going to get my camera to refocus. Alright, so n minus 5, n minus 3 equals 0, and I can flippy flip. I can flip the signs. 5 and 3 are my two solutions. We must check for extraneous solutions. Let's stick in a 5. 2 times 5 is 10. 10 minus 6 is 4. The square root of 4 is 2. Sticking a 5, 5 minus 3 is 2. Okay, so the 5 checks. What about the 3? 2 times 3 is 6. 6 minus 6 is 0. The square root of 0 is 0. And of course, 3 minus 3 is 0. I can have 0 equals 0. That's perfectly valid. I just can't take the square root of a negative number. So 5 and 3 are good solutions to that radical equation. And the last one, the trickiest of them all, is when I have a couple of square root, a couple of radicals, and then I have a third number. First of all, both of these on the left-hand side of the equal sign, I can't have that. I've got to isolate at least one of these guys. Okay, since this one is negative, I'll move this guy to the other side. That way I don't have to deal with any negative radicals. So on the left, I'm going to be left with the square root of 6 minus k. On the right, it doesn't matter which one of these you put first. On the right, I will have the square root of negative 2 minus k, and then I can't forget about this 2 plus 2. Okay, now I've got one of my radicals isolated, so now I'm ready to take the square root of both sides. Now here's tricky, guys. You must, just like I showed you up here, you have to square the whole side of the equation. Okay, you can't do these individually. It doesn't work that way. So when I square the square root of 6 minus k, I'm left with 6 minus k. Alright, so now is where it starts to get a little tricky. I've got to FOIL this out. Okay, so I'm going to, maybe I should come over here to the side, maybe do this in, I don't know, let's do an orange. So we've got square root of negative 2 minus k plus 2 times another square root of negative 2 minus k plus 2. Okay, so when I FOIL first times first, when I multiply the square root of negative 2 minus k times the square root of negative 2 minus k, that's basically the same thing as squaring this. That means the square root just drops out. So I'm going to be left with negative 2 minus k over here. All right, now when I do that times 2 for the outside, I'm going to have 2 times that. So plus 2 times the square root of negative 2 minus k. When I do the inside, I'm going to have the same thing. I'm going to have another 2 times the square root of negative 2 minus k. And then when I do the last, 2 times 2, I will have a 4 on the end. Okay, a little tricky there. And so now it's just a bunch of simplifying. Okay, first thing I notice is I've got a negative k on the left and a negative k on the right. So if I add k to both sides, those guys just disappear. They go away. Okay, these 2's don't cancel. Don't make this mistake. I can't say, oh, I got a negative 2 and a 2. Those cancel because this is being multiplied by this, and that's just a number by itself. Okay, so I've got to add these two guys together. All right, so but before I do that, I can combine the 4 and the negative 2. So on the left, I have 4 minus 2, which is going to be 2. And now I've got two of these guys. I've got 2 apples plus 2 apples. I have 4 apples. So 4 of those guys, negative 2 minus k. All right, now let's go ahead and move the 2 to the other side. 4 equals 4 times the square root of negative 2 minus k. Now I still need to isolate this guy, get it by itself. That means I need to divide both sides by 4. And then everything just cancels, and I'm left with a 1 on the left. So I'll have the square root of negative 2 minus k equals 1. 4 over 4 is just 1. Now, I know, now we've got to do it again. Take the square of both sides. All right, the square root of negative 2 minus k squared is negative 2 minus k. The square, 1 squared, of course, is just 1. Move the k to the other side. Subtract 1 from both sides, and I get k is equal to negative 3. K equals negative 2 minus 1, just so you can see that. Okay, is that extraneous? Let's plug it in. Okay, so if I plug in a negative 3, I've got 6 minus a negative 3. That's 6 plus 3, which is 9. The square root of 9 is 3. And then over here I've got negative 2 minus a negative 3. That's negative 2 plus 3, which is 1. Okay, so I have 3 minus 1, that equals 2. There you go. So in this case, all 4 of our solutions were perfectly valid. No extraneous solutions. Okay, so now let's enter the world of rational exponents. When you see this word rational, just like I've taught you guys in class, you need to think fraction. Okay, so now we've got all these fractional exponents, and we're going to be able to use all the exponent rules that you guys learned several years ago. The product rule when I add my exponents, the power rule when I multiply my exponents, the quotient rule when I subtract my exponents. These first few ones, however, are pretty straightforward. When I simplify, there's no variable here. Okay, so when I say evaluate or simplify, that just means that we're just going to rearrange this into some number. Now, I'm totally fine with you guys just doing this on the calculator, or if you want to remember, the way that I taught you is this is your power and this is your index. So it's always power over index. Okay, so when I want to, if I wanted to rewrite this as a radical, all right, I've got there's my radical, the 343 goes inside, so where's my index? My index is 3, okay, and the index goes in the little crevice of your square root symbol. So we're taking the cube root, my power, technically we're raising everything to the first power, and of course I don't need to write that. So essentially we're just asking what is the cube root of 343, which is 7. Okay, of course we can just type this on our calculator and get the answer. 343 raised to the 1 divided by 3, and our calculator spits out 7. Okay, how do you do the cube root on your calculator? For those of you who might not know still, you're going to press the math button here, and then you can see option number 4 is the cube root. So if I selected that, the cube root of 343, of course, is 7. Okay, so here they want us to go back and forth, switching between the rational exponent and the radical. Okay, so here I'm in my exponential form. Okay, so I got my exponent. All right, there is my power. There is my index. Power over index. Okay, so square root. Now it's a huge that you guys understand that 7a with the parentheses around it is totally different than 7a to the negative 5 halves. Those two guys are completely different things. In this case, I'm raising the 7a to the negative 5 halves power. In this one, I'm only raising the a to the negative 5 halves power. The 7 doesn't get to play because it's not in parentheses. Okay, big difference. But in this case, all of it is, so all of it goes inside the parentheses. And my power is 5, okay, but it's a negative 5. And my index is 2. So this will be the second root of all of this raised to the negative 5. But since it's a negative exponent, I've got to put this on the bottom. Okay, so this is going to be 1 over, and I don't need to write the second root. Okay, second root, the square root. 1, 2, length times width. I'm taking the second root. So if there's nothing there, guys, it's understood to be the second root, the square root. So I don't need to write that. So I'll just write square root of 7a, and all of that is being raised to the 5th power. Okay, power over the understood index of 2. Number 7, we're going backwards. We're starting with a radical and we're going to the exponent. Okay, so there is my power, and there the 5 is my index. Okay, power over index, power over index. All right, so this is going to be 10x raised to the power over index, 3 over 5. But notice that all of this was on the bottom. So that means my exponent is going to be negative 10x to the negative 3/5. Okay. All right, let's move on. Now we start to get into our exponent rules. Simplify. Your answer should contain only positive exponents, so no negative exponents in your final answer, and no fractional exponents in the denominator. So you can't have a y to the 4/3 down on the bottom. Okay, so number 8 here. All right, so the first thing I notice is I have a 2 and a 2, and neither of those are in parentheses. So I'm not raising either of the 2's to any power. So when that's the case, these are basically just coefficients. So you can just multiply those together. 2 times 2 gives me 4. I know I'm going to have a 4 in my final answer. Okay, I might have some stuff on the top. I might have some stuff on the bottom. There's definitely going to be a 4 on top. All right, so now notice that I have x times x to the 3/2. Okay, so this is basically an x to the 1. All right, so if I have x to the 1 times x to the 3/2, this is my product rule. Product means you multiply two things together. When I multiply x times x to the 3/2, I need to add these exponents. Anytime you add or subtract fractions, rational fractions, you must get a common denominator. Okay, so the common denominator, anytime you have one of your exponents is just a whole number like 1 or 3, then the common denominator is going to be the denominator of the fraction. Okay, so maybe I should do this in different colors. Okay, so the common denominator is going to be 2. Well, how do I get 1 to have a denominator of 2? This is technically 1 over 1, correct? So what I need to do is, since I need a common denominator of 2, I need to multiply this guy by 2 over 2. Okay, when I multiply 2 over 2, 2 over 2 is just 1. So I'm basically multiplying 1 times 1. I'm not changing anything, but now that allows me to have 4x to the 2/2. 2 over 2 is 1. It's still x to the 1, but now I have x to the 3/2. Now notice that I have common denominators, and now I can add these together. I'm going to add across the top 2 plus 3, and that gives me 4x to the 5/2. Okay, by the way, can I check all these guys? Can I check these on my calculator? Absolutely you can, absolutely. Let's go back up here and let's type this one in. Okay, so I'm starting with my original problem, parentheses 7 alpha a, parentheses raised to the negative 5 divided by 2. Let's get some number. Okay, whatever, fine. We think that's the same thing as 1 over the square root of 7a all to the 5th power. Okay, 1 divided by parentheses the square root of parentheses. Actually, I don't need, depending on your calculator, you may or may not need parentheses inside. 7a. Okay, now notice that I'm still under the radical. So to get out of that, I got to press the over button. Now I'm outside the radical, and now I can close the parentheses and raise that to the 5th power. And you can see that the numbers match. So that confirms that this is the same thing as this. Okay, I can do the same thing on the next one. Now this one's actually a little bit trickier. How do I do the 5th root? Well, on your calculator, if you press math, notice that you have the x root, or a lot of times we call it the nth root, the 5th root, the 12th root, the millionth root. Okay, so if you want to take the 5th root, you're going to have to type in 5 and then press math and then click this option. Okay, so if I want to go back and type this into my calculator, I've got to do 1 divided by All right, parentheses, I want the fifth root. So I've got to press 5 and then go Math, select this option. And now you see my calculators put the index of 5. Now I'm taking the fifth root of 10x. Okay, get outside the radical, close your parentheses, and raise that to the third power. That's the same thing as 1 over the fifth root of 10x raised to the third. Get some number, fine. We think that's the same thing as parentheses 10x, close the parentheses, raised to the negative 3/5. And they match. Okay, so just showing you guys how you can check these. All right, what about this one here? These start to get a little bit more complicated when you start checking these, okay? But the more you practice, the faster you'll get. Let's type in exactly what we see. 2x raised to the 3 divided by 2. Get some number, fine. We think that's the same thing as 4x raised to the 5/2. All right, they match. Move on to the next one. Feeling good. Okay, number 9. And this, guys, is exactly why I have taught you guys to assign numbers to all the letters in your calculator, so that when you have A's and B's and X, Y's and Z's, then you don't have to worry about it. If there's only one number, you know, if this were a 2r times 2r to the 3/2, just use X. Yeah, you just use the X button. Just use the X button. But there are multiple variables, then you can use the little trick that I've taught you how to do. Okay, so this is another product rule. I am simply, zoom in here a little bit. Okay, so I can simply add the exponents together. But notice this is an a to the first, and this is an a to the 5/4. This 4 is not in the parentheses, so I know there's going to be a 4 in my final answer. Now I've got to add the 1 plus the 5/4. Okay, all right, so my common denominator for the a's is the 4. That means I need to multiply the 1 by 4 over 4. Okay, so that's going to give me 4a to the 4/4. 4 over 4 is just a to the 1. It's the same thing. And I'm going to match this up with the other a to the 5/4. Okay, now it's time to do the b's. Okay, let me come out here to the side and kind of do these. I'll come down here. I've got b to the 4/3 times b to the 1/4. Well, 3 doesn't go into 4. Okay, so I've got to find the common denominator. And if you're not sure how to get the common denominator, you can always just multiply these together. 3 times 4 is 12. Okay, that is the least common multiple. That is going to be our greatest common denominator, or our common denominator. Okay, so that means that I need to multiply the 4/3. I need to get to 12. How do I do that? I need to multiply this guy by 4 over 4. And I need to multiply the 1/4 by what? 3 over 3. That will give me b to the 4/4 times b, if I multiply across the top and bottom, 3/12. Oh, sorry. Let me back up. Here. Back up here. I can go ahead and knock this out in one step. Go ahead and multiply these together. No reason to skip that step. Okay, so if I multiply across the top here, 4 times 4 gives me 16, and then 3 times 4 gives me the 12. Okay, so I got b to the 16/12 times b to the 3/12. Okay, so now let's go back up here, back in purple. So now I've got b to the 16/12 times b to the 3/12. Okay, do yourself a favor and do a little 1-second gut check and go back and make sure, is 4/4 the same thing, is a to the 4/4 the same thing as a to the 1? Yes. We left that alone. Is 16/12 the same thing as 4/3? If I divide the top and bottom by 4, 4/3, yes. Is 3/12 the same thing as 1/4? Yes, it is. So do those quick little gut checks just to make sure that when you get in your common denominator and you're messing around with these fractions that you haven't made a mistake. All right, so now I'm ready to add my exponents. That's going to be 4. I just add across the top, 4 plus 5. That's going to be 4 to the 4a to the 9/4, and then add across the top here, b to the 19/12. Okay. Is there anything else I can do? Can I simplify my exponents? No, I can't. So that's my final answer. All right, so let me show you how to do this one with the different variables. Okay, let's type in exactly what we see here. Alpha A, alpha B raised to the 4/3. Depending on your calculator, you may have to press the over button to drop your cursor back down. There we go. Okay, and then I have 4. You don't need to press times. Your calculator knows that if there's nothing, no operation there, it assumes it's multiplication. 4 alpha A raised to the 5 divided by 4, drop my cursor down, alpha B raised to the 1 divided by 4, and we get some number, okay, whatever, 425. We think that's the same as 4 alpha A raised to the 9 divided by 4, drop my cursor, alpha B raised to the 19 divided by 12, drum roll, bam, love it. Love it when they match. Lets me know I've done it correctly. All right, let's move on over to the back, to the left, to the right, to the back. Okay, this one's super easy. This one should take you approximately 3/1000ths of a second, give or take. All right, so this is the power rule. When I have an exponent raised to an exponent, what do? I multiply those together. 1/2 times 1/4 is x to the 1/8. Nothing to do there. Okay, number 11. All right, so now I've got something on the top and the bottom. When you have a variable on top and the bottom, then that is where the quotient rule comes into play, and I'm going to subtract my exponents. But before that, I notice that there's a 2/4. So I already know, I'm already anticipating that my final answer is going to be a 1/2. There might be some stuff up top, up bottom, there might be stuff in both places, but I know there's going to be a 1/2 in my final answer. All right, now I'm ready to do the quotient rule. This is x to the 1. I've got to subtract 1 minus a 1/2. Okay, and guys, I saw that there was some confusion today during the lesson. When you do the quotient rule, it's always the top minus the bottom. Okay, if I have you know, a to the m over a to the n, that's going to be a to the m minus n. Is top minus bottom. Okay, it doesn't matter that one of these is a negative. Okay, don't worry about that. If the m is negative and the n's negative, or the m is positive and the n's negative, don't worry about that. It's always going to be top minus bottom. Let the negative play out, and then you can flip at the end. Okay, so now I'm ready to do x to the 1. Okay, and then I'm subtracting a negative 1/2. So that's 1 minus a 1/2. Okay, so on top I'm going to have, all right, so I've got to get a common denominator. What's my common denominator? My common denominator is 2. So I need to multiply this by 2/2. So that's going to be x to the 2/2. That's a negative. Okay, subtracting a negative 1/2. Negative and a negative makes that a positive. So that's going to be x to the 2/2 plus 1/2. And all of that is over 2. Okay, so now I add my exponents. That's going to be x to the 2 plus 1, x to the 3/2 over 2. And I don't need to write a 1 right there. Okay, let's check it. All right, got to make sure this stuff's in parentheses. 2x divided by parentheses 4x raised to the negative 1 divided by 2. Drop my cursor down, close the parentheses. Okay, and let's type in x raised to the 3 divided by 2. Drop my cursor down, divided by 2, and voila, they match. Number 12 is super easy. All you need to do is use the power rule. Multiply both of these by 4. X to the 1 times 4 is going to be x to the 4th, and then 7/4 times 4, or times 4 over 1, the 4's cancel. I just have y to the 7th. Okay, number 13, got several different things going on here. I always want to see if I can do the product rule first. Can I simplify? You always want to simplify first, kind of work your way from inside out. Okay, but there's nothing else I can do on the outside. I've got an A and a B, so I'm stuck. Okay, so here I probably would just go, and inside I'm stuck. I can't simplify inside. So here I would go ahead and use the power rule and multiply those together. So I have a to the -2, b to the -1. Let's just leave that for a second. And guys, these concepts in lesson can be a little bit tricky because most of the time in math there's pretty much a straightforward way, a process, a procedure for solving these problems to get the right answer. But this is one of those cases in math where I can't sit here and tell you there's one right way to do this. I mean, I could literally have 5 different students work this problem and come up with 5 different ways to do it, and they would all come up with the same they all come up with the same exact answer. Okay, could I write out the gate? Could I go ahead and put the a to the -2 and the b to the -1 on bottom and have an a squared b on the bottom? Absolutely, you could do that. There's nothing wrong with that. Okay, you're going to get the same answer. But I'm always looking to see what's going to cause me the least amount of work. What's going to suit my eye visually better? Do I need to flip this? Do I need to simplify this first? And as a general rule of thumb, you want to do the product rule and simplify stuff inside the parentheses first. Okay, but we don't have that here. So yes, I would go ahead and use my power rule. I'm going to multiply -1 times 2. That's going to give me a to another -2. And then 3/4 times 2, or times 2 over 1, is going to give me b to the 6/4. Okay, I'm going to go ahead and just take the time here just to rewrite this very, very quickly. A to the -2, b to the -1, a to the -2. 6/4 is the same thing as 3/2. Okay. All right, so now I'm ready to start adding stuff together. For my a's, I've got -2 and -2. I don't have fractions, so I can just add those together. That's going to be a to the -4. Now for the b's, I need a common denominator of 2. So that means I need to multiply this guy by 2 over 2. So that's going to give me b to the -2/2, which is the same thing as b to the -1. And then another b to the 3/2. Okay, so that's going to give me a to the 4th. -2 plus 3 is 1. So that's going to be b to the 1/2. And this a to the -4 is negative, so I got to put this guy on bottom. So the b to the 1/2 stays on top. The a to the 4th goes on the bottom. Okay, I can check that very quickly. All right, so we got alpha a to the -2, alpha b raised to the -1. Whoops, almost made that mistake. I didn't drop my cursor down. Alpha a raised to the -2, drop my cursor. B to the -1, drop my cursor. Big parentheses, a to the -1, drop the cursor. B to the 3 divided by 4, drop the cursor, parentheses, all that raised to the 2nd power. Okay, fine, whatever. Don't care what that number is. Alpha b raised to the 1/2. Now I could do 1/2. I could actually do 0.5 if I wanted to. B to the 1/2 is the same thing. Divided by alpha a to the 4th, and they match. Okay, 3 more, guys, home stretch. Ooh, getting into some tricky stuff, tricky. Mr. Maniz, why? Why do we have to do these long, complicated problems, Mr. Maniz? Why can't they all be like this? I'll give you a hint. Companies want to know if you can do this. This is hard. This is hard. Companies want to know, can you navigate through a long, complicated, advanced algebra problem? You'll never do this in your job. You probably won't. Doesn't matter. You're building a skill. Can I do all this without making a mistake? And if I do make a mistake, am I willing to go back and check and fix it? Okay, that's a skill. Companies are looking for that stuff. Okay. All right, now here's a perfect example, guys. A perfect example where, man, you could literally do this. Start off doing like 3 or 4 different things. Okay. Some students may look at this and say, well, why not just flip and put the y squared down here? Some students may look at this and say, why not take all of this and move it up top and make it a 5/3? Why not just go ahead and simplify the bottom first and don't mess with any of that flipping stuff? Okay. And all of those answers and all of those different paths would be correct. It's just, I can't tell you in this particular case what the right thing to do. Here's what I would do. Normally, guys, I save my flipping until the end. Unless I have something a whole bunch of stuff raised to the -1. So if I had a problem, I'll just come down here and say I had a problem like this. Say x to the 4/3, y to the 3/2, z to the -3, and all that's being raised to the -2, and all that's over blah, 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 blah. Yeah, in this case, I would probably right out the gate, I would probably take this whole thing, if it's more than one thing in the parentheses, I'd take that whole thing and put it on the bottom. Y to the 3/2, z to -3, all that being squared. Yeah, I would probably do that, okay? But typically, I save my flipping to the end. However, in this case, I'm going to make an exception in this case, because if I flip this y, guess what I'm left with? I'm left with a nice clean 1 on top. And that just kind of sits my eye visually better, okay? So if I flip this, anytime I can get the numerator to be equal 1 or the denominator to equal 1, that's a lot less intimidating. So in this case, I'm going to go ahead and flip the y to the -2. So that means I'm going to have a 1 over y squared, y on the bottom, x to the 5/4, parentheses, x squared, y squared, all raised to the -5/3. Now if I look at that, if I just given you this problem, that doesn't look near as intimidating as something like that, right? I got a nice pretty 1 on top, okay? All right, so let's go ahead and see if we can simplify, okay? I can simplify the y's down here. And this is another reason why I would do this, is because I've got a y up here and a y down here. I'll be able to combine these without having to do some kind of quotient rule, okay? So this is going to leave me with 1 over, I can go ahead and combine those, 2 plus that understood 1, that's going to give me a y cubed. And then I have x to the 5/4. And then I'm going to go ahead and use the power rule, multiply these two guys times the -5/3. Okay, 2 times the -5/3 is -10/3. Same thing here, y to the -10/3. Okay. All right, now it's time to get some common denominators. Okay, so for my x's, I have x to the 5/4 and x to the -10/3. Okay, so what's the common denominator for the x's? 4 times 3 is 12. Okay, so that's going to give me 1 over, I need to multiply this guy by 3, so that's going to be x to the 15/12. And I need to multiply this guy by 4. That's going to be x to the -40/12. On something like this, take just a second. Is 15/12 the same thing as 5/4? Divide the top and bottom by 3. 5/4, yes. Divide the top and the bottom by 4. -10/3, yes. All right, now for my y's, I've got a 3 and then a 3 in the denominator. So my common denominator is 3, which means I need to multiply this guy by 3. So this will be the same thing as y to the 9/3. 9/3 is the same thing as y cubed. And then times the y to the -10/3. Okay. All right, we're getting there. So it's going to be 1 over 15 minus 40 is -25. So x to the -25/12. And then for the y's, 9 minus 10. Come on, you can do it. There you go. Okay, for the y's, I have 9 minus 10, which is -1. Okay, so that's going to be -1/3. Okay. Now notice both of these guys are negative, so now is where I usually just save my flipping until the end. If I put both of these guys on top, flip it, that's going to be x to the +25/12 and y to the +1/3. Remember, anytime you flip stuff, move it from the top to the bottom, bottom to top, that exponent sign flips. Okay. All right. Let's move on to number 15. First thing I notice is something raised to the 0 power. Anything to the 0 power is 1, so that just goes away. I can't combine anything inside the parentheses, can't simplify on the bottom, so yes, let's go ahead and use our power rule and multiply. I'm going to do the x's first. I don't know why they put the y's in front. It's kind of weird, but x to the 1/3 times 2 is going to be x to the 2/3 on top. and then I have the y to the 4/3. Oops, excuse me. Whoops. I also have to multiply the 4/3 times 2. Okay. 4/3 times 2 gives me 8/3. All right, and all of that's going to be over x to the negative 1 y. All right, now I'm ready to do my quotient rule. I'm going to subtract 2/3 minus a negative 1. Okay, now when you do the quotient rule, everything's on top. When I do that minus that, you put everything on top. And then you flip at the end if you need to. So this is going to be x to the 2/3 minus a negative 1. All right, and for the y's, it's going to be the 8/3 on top minus this understood 1. Okay, so for the x's, I need a common denominator of 3. So I need to multiply this guy by 3 over 3. So that's going to give me x to the 2/3. Now, minus a negative is a positive, plus 3/3. Okay, same thing as 1, and I'm adding 1. And then for the y's, same thing. I need a common denominator of 3, so that's going to be y to the 8/3 minus 3/3. 3/3 is the same thing as 1. And now I can finally add. That'll give me 2 plus 3, x to the 5/3, and 8 minus 3. The y is also 5/3. Okay, I could check that one very quickly. Okay, big parentheses, alpha y raised to the 4/3, x raised to the 1/3. I'll go ahead and put in the alpha y raised to the 0, but we know that's just 1 squared. No. Nice. Okay, take 2. Parentheses, alpha y raised to the 4/3, x raised to the 1/3, alpha y raised to the 0, parentheses, squared, divided by, parentheses, now I got to put all that in parentheses, so my calculator knows I'm dividing by all of this, alpha y x raised to the negative 1. Drop the cursor, close the parentheses, I get that huge number. Okay. Now let's do x raised to the 5/3. Drop the cursor, alpha y raised to the 5/3. And they match. All right. Last one, the home stretch. Home stretch. This is the most difficult. Okay, so I've got something on the bottom here. Okay, got something on the bottom. Again, I usually save my flipping until the end. However, do you think it would be better if we flipped all this first? Remember, I said anytime I can get a 1 on top or a 1 on the bottom, I'm going to do that. So if I move this, now if there was some other stuff out here, if there were like an x squared or y to the negative 3 or something like that else out here, I probably wouldn't flip it. Okay, but since there's nothing else here, why don't we go ahead and move this guy and we'll just have a 1 on the bottom. Okay, so I'm going to rewrite this as x to the 2/3, x squared, y to the 4/3, and then all of this stuff, x to the negative 1, y to the 4/3, to the positive 3/2. Once again, if I just gave you guys this problem, you would look at that and say, that doesn't look so bad. When you look at this, you want to vomit on the floor, right? And so it looks scary, it looks intimidating, but if you just make one little change, one little adjustment, it's not near as scary, okay? All right, so now I'm ready to start combining stuff. I can't combine inside the parentheses, but I can combine outside. All right, so I need a common denominator of 3 for these two x's. That means I'm going to need to multiply this 2 by 3 over 3. Okay, so that's going to be x to the 2/3 times x to the, if I multiply 2 times 3, that's 6. And isn't 6/3 the same thing as 2? And then I have the y to the 4/3, and then times all of this stuff. Okay, so now let's go ahead and combine these. That's going to be x to the 8/3 y to the 4/3, and now I can go ahead and multiply this. And I would say, guys, if you got up to here and you stopped here and you wanted to wait until you multiply these and then get a common denominator, you absolutely could do that. Absolutely. In fact, I'm doing this two different ways. On the quiz review answer key that I posted online, I left this alone. And I multiplied this, and then I got a common denominator between all three of those things. In this video, I'm going to go ahead and combine these guys and then get a common denominator with this. You're going to get the same answers. Just you're the boss. You're in control of how you want to do this. All right, so here I'm going to multiply -1 times 3/2. That gives me x to the -3/2. And then I multiply the 4/3 times 3/2 for the y. So that's going to give me 12/6. Okay, which of course we know is just 2. I'm actually going to leave that. Now if you wanted to write a 2, you could, but I'm going to leave that because I'm going to have to get a common denominator of 6 anyway if I leave it like this, so maybe that's a little bit easier. Okay, so now for the x's, I need a common denominator of the 3 and the 2. I need a common denominator of 6, so I need to multiply this guy by 2/2. For the y, for this one, or I'll stay on the x's. For the x's, I need to multiply this guy by 3/3. For the y's, do this in blue, I need a common denominator of 6, so I need to multiply this guy by 2/2. And now we got a whole bunch of common denominators. So 2 times 8 is 16, so this is going to be 16/6, x to the 16/6. All right, and then I'll match that up with this x. -3 times 3 is -9, so I got x to the -9/6. Okay. All right, when I multiply this, 4 times 2 is 8. So for the y's, that's going to be 8/6. And then for the other y, I have the 12/6. Okay. All right, now I'm ready to add these together. 16 minus 9 is 7. So that's x to the 7/6. And then if I add those, 8 plus 12, that's going to give me 20/6. And the last thing I need to do is just simplify this 26. That's going to give me x to the 7/6. Y, divide the top and bottom by 2. 10/3. That's a lot of stuff, Mr. Manise. Do I really have to check this, Mr. Manise? Do I have to check it? No. No. No, you don't have to check it. Are you willing to lose 8 points on your quiz because you made a mistake and you worked the whole problem wrong? That's a question only you can answer. You know where I stand on this. Okay. Now, something like this, guys, putting this into your calculator, I'm going to work through this just so y'all can see this. Yeah, you can enter in exactly the way you see this, but my gosh, that is going to be a ton of different parentheses that you have to use to make sure you're doing this correctly. Probably what I would do is I would go ahead and go straight to the point where I flipped, where we put all of this on top, and type this in your calculator. Isn't that a lot easier to type in than all that stuff? Yeah, Mr. Manise, it is. Good. Okay, so let's type this in. X raised to the 2/3, drop the cursor, x squared, alpha y raised to the 4 divided by 3, drop the cursor, parentheses x to the -1, drop the cursor, alpha y raised to the 4/3, drop the cursor, parentheses, all that, raised to the 3/2. Okay, good Lord of mercy. 2.3 times 10 to the 12th power. Fine, whatever. We don't care. Okay, let's type in our. We think that's the same thing as x raised to the 7 divided by 6. Drop the cursor, alpha y raised to the 10/3. Drum roll. I'm scared. Boom. And I made 100 on my quiz. I've checked all of the radical equations. I've plugged them back in and make sure there are no extraneous solutions. I know those are right. I've checked every single one of these guys. Okay, so if you guys are prepared, you can walk in here, knock out the problems, and have maybe 5 or 10 minutes to spare. Then go back and check every single one of these, make 100, confetti falls from the sky, and you can go sit back at your desk and daydream about Snicker bars. Okay, I hope you guys enjoyed this video and wish you good luck on your quiz. We'll see you on the next one.